we have basically come to the pinnacle of our competitive market theory. So we have built it up from understanding consumer theory and producer theory to partial equilibrium, which is one market, to market dynamics in a competitive market in the short run and the long run, to general equilibrium, which is looking at all markets at once. We have, that's kind of a benchmark model in economics. So now we have a good understanding of that. We should have a solid understanding of that. And that also means that we got to, as I said earlier, as deep as we'll go in this course into economic theory. But one question that never came up really is pricing. So why did pricing never come up? Because in a competitive market, the answer is right here in this picture. In a competitive market, how is price determined? Well, it's determined by supply and demand. So pricing is, in fact, it's a matter for us theorists. It's for us to try to predict, what is market price going to be? What is it likely to be? As we look at a market, as we look at an economy. We can solve for it theoretically, but those actors in the market, they don't have much of a decision-making process when it comes to pricing. Because if you are selling tomatoes at the farmer's market and there are 15 other stands selling essentially exactly the same tomatoes, how much you'll charge is not much of a question. You'll basically charge what everyone else is charging. If you're selling about the same tomatoes, you don't have much of a choice. So that's why for us, it's a theoretical matter for us to think about what market price is going to be. But it's not much of a question for those sellers or those buyers. How much am I going to ask for or how much am I going to charge? It's not much of a question because it's a competitive market and nobody has pricing power. Okay, in reality, do firms or sometimes buyers have pricing power? Well, very often they seem to, right? So we see lots of situations in which sellers or sometimes buyers have pricing power. In fact, if you look around, it almost seems like in most cases they have pricing power. So the competitive model is very important as a basic benchmark model in economics, and it actually is very useful in a number of applications. But if you think about the assumption of all actors being price takers, that doesn't seem to hold very often. Maybe on the consumer side, like when we go shopping, maybe it holds that we are price takers the way we make our decisions. We don't have pricing power in the markets in which we buy. We usually don't have pricing power in the markets in which we sell either, actually. But if you think about companies and products and most products that you buy, it's not too difficult to see that there is quite a bit of pricing power in those markets. So what we'll do next is try to understand that kind of market, that kind of situation. How do those firms make those decisions? How much do they choose to charge? What does that mean for welfare, for example? What kind of regulations are there in place as a result of that kind of pricing power or market power? Those are the questions we'll be asking. And the simplest way to start asking those questions is for a monopoly, because a monopoly has perfect pricing power. So you can imagine various degrees of pricing power. You have some market power or you have more market power, but a monopoly has complete market power. It sells a unique product that nobody else sells and has complete power over quantity and price. So the most easy way to start asking this question about pricing is by looking at a monopoly. How would a monopoly make its decisions? How much to produce? How much to charge for it? And of course, those decisions are made with an eye to maximizing profit. So a monopolist who maximizes profit and chooses price and quantity, that would be the simplest model for understanding pricing power. Okay. One other thing I want to add right at the beginning is that this topic is very, very interesting from a number of perspectives, as I hope you'll see over the next week. It's interesting, of course, it's interesting theoretically, for me, and maybe for you in a bit. But it's also very interesting in an applied way. So if you're a company and you're pricing, how do you make those decisions? So firms actually are really interested in knowing this kind of stuff. And people who know better than I know claim that even today, many firms are not very good at this. So it's not that long ago that they started realizing that pricing is really important. And you might think, well, how could that possibly be? I mean, how could pricing not be important? And it's not that they didn't think it was important. It's just that it's usually a lot easier to think about costs. It's a lot easier to think about how could we reduce costs than to think about what would be the right way to price. And so pricing used to be, in many cases, kind of an afterthought. Like, well, once we get there, we'll charge as much as we can, basically, and we'll do that. But it turns out that pricing is actually very complicated and very interesting, and there are many, many ways to price. So it's a whole field in itself, and we'll just sort of touch on the surface. But even that is very interesting. So it's interesting from an applied perspective, but it's also interesting from a policy perspective. Because as we'll talk about, maybe next week, the government, of course, is interested in how firms use market power, because that has all kinds of welfare implications. So we'll talk about how the government is trying to understand whether firms are using market power in a way that is hurting the economy or consumers in some sense. So how do they look at those questions? Well, they need models, right? They need economic models. And so they need to look at the kinds of models that we are about to study, and then also oligopoly models to try to understand situations in which firms are using market power. So this is a really, really interesting topic from a variety of different perspectives. Let's start with the basics. Okay, if you're a monopoly, what does that mean? It means you have a market all to yourself, right? So that means there are consumers, and they are along this demand curve. So how do we show them? They are right here. These are your consumers. They have different valuations, and those are represented by points on the demand curve. And you're selling to them, and you're going to charge some price and choose some quantity that you're selling. Now, are you choosing the quantity or are you choosing the price? Well, you're choosing both. But the point is, you're choosing. You don't have complete power to decide price and quantity. You can essentially choose one. How is that? Well, if you choose to sell at this price, the demand curve will dictate that you'll be selling a certain quantity, right? If you're selling at this lower price, the demand curve again will dictate you'll be selling this larger quantity. So once you choose a price, the quantity is essentially whatever you can sell at that price, given your demand. Alternatively, you could choose quantity too. You could say, this is how much I'm going to sell. That automatically means, if this is how much you want to sell, that automatically means you need to charge this price, because that's how you can sell this much. So one determines the other via the demand curve, right away. Usually, the variable we'll look at will actually be quantity. But that's not because we think that that's how monopolists think. It's just that it turns out to be more convenient mathematically, but it's the same thing as choosing price because of the connection between the two that's given by the demand curve. Okay, so because we will be looking at quantity as the variable of choice, the demand curve, which usually depends on price, is not a really convenient way to actually formalize demand. Because what we really want to know, what we really need is a function of quantity if we are going to look at quantity as a decision variable. So this demand curve, for us, would work better if it were dependent on quantity and not price. And for that reason, we actually use the inverse demand curve. How do we get that? So the inverse demand curve will ideally depend on quantity, right? So it's going to tell us what price you'll need to charge if you want to sell a certain quantity, as opposed to how much you'll sell if you charge a certain price. So it's just the inverse of the demand curve. It's not very complicated, but how do we get it? Well, the demand curve would tell us the quantity that you can sell given some price, right? So the inverse demand curve basically will mean you'll solve this equation for P. Okay? you'll take the inverse of that function, and you'll solve it for p. And we could write it as you'll take the inverse of that function, and that will be this, which is p. And that in fact will be, so that will be the inverse demand curve. With a specific example, this will be more clear. But generally, we want, instead of this, we really want the inverse demand curve. Okay. So a monopolist is looking at this demand, and how are they going to maximize profits? Well, one side is revenue, the other side is cost, right? So that's profit. So cost is, let's say, is represented by this marginal cost curve. But of course, we know that that corresponds to the total cost curve. So by now, we have pretty good facility with this, and we can go back and forth mentally between. We have this marginal cost curve, but we know that there's also a total cost curve that corresponds to this. What is it going to look like? If this is the marginal cost curve, what does the total cost curve look like? I don't think it would be parallel. This is marginal cost. What would total cost look like? Just approximately. If you had to draw it, you're drawing like a parabola, quadratic, about, because this looks about linear. And so if marginal cost, which is the derivative of total cost, is about linear, then total cost is about quadratic. Okay, so we know that, we have that in the back of our minds. But the point is, we are looking at revenue minus cost. So what's revenue? Well, it's price times quantity. Okay, price actually can be written as a function of quantity, because that's what the inverse demand function does. So given some quantity, this is how much you can charge. That's the inverse demand function. And then that we multiply that by quantity. So that's revenue minus total cost. That's profit. Okay, so in general, we'll look at examples, but in general, if you were to maximize profit, you would take the derivative of this, right, and set it equal to 0, assuming that it has a maximum, and we'll assume for now that it has a maximum. And then, we can solve for quantity. All of this depends on quantity. We should be able to solve for quantity in theory, and then get the profit maximizing quantity, and thereby the price also. Okay, so what's the derivative of this function with respect to quantity? Think about that.
So TC going to be the MC, that is pretty easy.
Yeah, so the cost side is easy, because the derivative of total cost is marginal cost. Okay, so that's easy. Now what's the derivative of total revenue here?
Just price. Just price.
So I've heard just price. I've heard 3 different things. Just what did you say?
Marginal revenue versus the demand.
You said marginal revenue, which is really clever, because in economics, if I ask you what's the derivative of total anything, it's marginal anything, right? So that's very true.
But won't that also be a demand curve?
But what is that? Yeah, that's the question. So we could just take the derivative, right? It's right here in front of us. So let's just take the derivative. So this is the product of 2 functions. One function is PQ, P of Q, and the other function is just Q itself. So let's take the derivative. So we'll have dP divided by dQ. That's the I'm not divided by. So dP dQ, which is the derivative of the inverse demand function, times this plus the derivative of Q, which is just 1, times inverse demand. And that's it. And then minus the derivative of total cost. And that should be equal to 0, right? So, in fact, if we add marginal cost to both sides, we'll have this, which says marginal cost equals to marginal revenue. That's marginal revenue. Okay? Do you have any questions? Yes. So the marginal revenue here is the derivative of this total revenue, and this is the product of two functions, inverse demand and Q. And I took the derivative of that. And this is what you get. Okay, now let me show you something that's kind of interesting right away. Even this is completely general, right? I haven't told you what inverse demand is. I'm using a formula essentially so far. Okay, but look at this. So if I start from this and rearrange it a little bit, in particular, I want to, on one side, I want to have PQ minus MCQ, and on the other side, then we'll have negative the derivative of inverse demand times Q. And then we divide both sides by price. So I'm now going to, I'll drop the Q's. We know it's there, but I'll stop carrying it right now. So I'll divide both sides by price, and we get negative derivative of inverse demand times Q over P. Does this look familiar at all to anyone? You've seen this before. Does it look familiar at all? What is this? What do you think?
It's like the marginal value, or like the marginal utility of one thing over the other thing is one of the prices.
I don't know. I don't know. We are far from that right now.
Well, maybe then in the technical substitutions.
No, I think you're looking somewhere else. You've seen this, but I think you saw it in a somewhat different.
Oh, that exact.
context. Almost exactly the same thing. What is it?
Is elasticity?
It's almost elasticity. What's elasticity? It's the inverse of this. Elasticity is negative dq dp times p over q. That's elasticity. So, in fact, this is 1 over the elasticity. So this is 1 over the price elasticity of demand. Okay, so that's interesting, because here's what we got. If a monopolist is maximizing profit, then how will he choose price and quantity? In such a way that the markup, this is sometimes called the markup, price over cost divided by price. The markup is 1 over the elasticity. Okay? So that's called the inverse elasticity pricing rule. And this, by the way, if you read the book, which you should be doing, I'm following closely what's in the book for chapter 10. If you read the book, you'll see that this also, P minus MC over P, is used as a measure of monopoly power. It's called the Lerner index. It's a pretty simple measure, but it's used as a measure of monopoly power exactly because a monopolist will be, we know that the monopolist will have this set so that it's equal to the inverse elasticity, price elasticity of demand at that point. Right? Price elasticity of demand is not like a general property of demand, it's at a point. So at that point where, at the price and quantity that the monopolist is choosing, the inverse elasticity is equal to the markup. Okay, now one more question. So what if marginal cost is 0? What if we assume that we don't think about costs? Forget about costs, let's just worry about revenue, right? Marginal cost is 0, then what can we say? Profit is being maximized where what? where elasticity is 1. P over P, that's all we have, right? That's 1. 1 over elasticity will be 1. So elasticity is 1. Okay, so this also says if you're just looking at revenue, you're maximizing revenue where elasticity is 1. Okay, you see the answer now to the first question, right? You didn't have to do any calculations, right, to answer the question, what's elasticity at that point where you're maximizing revenue? It always is 1 where you're maximizing revenue. Yeah. Okay. So this is a kind of a general first approach to maximizing profit for a monopolist. Do you have any questions? What will happen next, like over the next week, is you will basically do this over and over in different contexts, in somewhat different ways. So let's do an example that's not completely specific. I'm still not giving you numbers, but it's much more specific than what we had before. I'm just going to say, let's assume that demand is linear. Okay, so far we've been just working with a completely general demand. Let's just say demand is linear, which means it's of this form. Demand, so D of P is A minus BP, so it's linear. Okay, why don't you take like half a minute to solve for inverse demand? What's the equation for inverse demand?
So A minus Q over B.
It's not quite. So the question is, inverse demand will give you, as opposed to giving you quantity as a function of price, will give you price as a function of quantity. What's inverse demand if this is demand?
Oh yeah, well, that's it. Minus Q over B.
So raise your hand if you have it. I'll give you a few more seconds. All right, so this is what I would do. Demand gives you quantity, so I would write Q equals A minus BP. And then I would solve for P. So you divide both sides by B, and you have to rearrange it a little bit to get P equals A over B minus 1 over BQ. Okay, that's inverse demand in this case. So what's profit?
Profit should be P times Q minus total cost. So it should
So
be.
it's price times quantity, which is revenue,
So it should be
minus
A
total
over
cost.
Q.
Okay, so let's do this together. Profit equals price, which is given by the inverse demand, times quantity. So we just need to multiply inverse demand by quantity to get revenue. Okay, so we multiply this by quantity, and we get A over B times Q minus 1 over B Q squared. And then we subtract total cost, right? That's profit. And now we take the derivative of that and set it equal to 0 to find the profit maximizing level of output and therefore price. Okay, so let's do that. The first part is going to be marginal revenue. So we just take the derivative. It's A over B minus 2 over B Q minus marginal cost. That's the derivative, and we set that equal to 0, and that's how we find the profit maximizing quantities. So
Q should be
it's
equal to A minus B.
we can't quite solve for Q, right? but we can say that A over B minus 2 over BQ should equal marginal cost. Right? If we set this equal to 0, that's what we get. Okay. I have an inverse demand curve graphed here, which is, let's say it corresponds to this demand curve. If you were to graph marginal revenue, like this part right here, that's really marginal revenue. If you were to graph that, what would it look like in that picture? Think about that for a moment. How can you graph it for yourself? So at least mentally or on a piece of paper, try to graph it. You can just copy down the the PQ axis and just draw a demand curve and graph marginal revenue. Do you have it? A good start would be to ask this question: what's that intercept? It's A over B. So the equation for inverse demand is A over B minus 1 over BQ. So that intercept, that's got to be A over B, right? Okay, what's the P-intercept for marginal revenue? What is the P-intercept for margin? If you graph marginal revenue in the same graph, what's going to be the price intercept?
It's almost like Q.
Well, it's A over B.
A.
But if you look at the formula right here, it's A over B minus 2 over BQ.
Yeah, so Q equals
Okay.
to half A.
So it's got to be the same intercept. It's going to start right there. Its slope. What is its slope? It's negative, and 2 over B, which is, if you compared it to the slope of the inverse demand curve, what would you say?
It's just negative.
More steep, less steep?
More steep.
More steep by how much? Double. It's twice as steep. Which means if you were to graph marginal revenue for a linear demand curve, here's what it would look like. It has the same price axis intercept, but it has twice the slope. Okay, so if we now look at the equation that says we are maximizing revenue, I'm sorry, profit. We are maximizing profit. Look at this equation. If we added marginal cost to this picture, so if I were to draw, let's say it looks like this. This is marginal cost. If I were to add that, where would the profit maximizing price and quantity be? Umer, where would it be? Where they intersect. So marginal revenue equals marginal cost is the equation that we got. We graphed both. So where they meet, right there, that is the profit maximizing level of output. What's the corresponding price? How can I get that in the picture? I need to go up to the demand curve, right? Or inverse demand curve. So I need to go up to here. And that is how much. That's the profit maximizing price right there. Price and quantity. Okay? So for a linear demand curve, that's what the picture looks like. If this were a competitive market, how much would be produced? How would we find that point? If this were a competitive market with this demand curve and that kind of cost structure for the industry, how much would be produced?
Where the MC and demand curves cross?
All the way out here, where the MC and demand curves cross. That's how much would be produced. So right away, here's what we can say. a monopoly will produce less than the competitive level of output and will charge a higher price. That's not a surprise, but we see it right here. Yeah, Umar?
In a competitive market, won't the margin revenue be equal to a demand?
Well, here's the difference. In a competitive market, if you are a seller, what's your marginal revenue?
Whatever your price is.
It's the price that is prevailing in the market, right? So that's the fundamental difference. You don't think about that because you take whatever price prevails in the market. You're a price taker. But here, as a monopolist, you're not. Okay. So by the way, that also means you don't have a supply curve. You don't have a supply curve that says at this price here's how much I would supply, and at this price here's, because you're setting both. You're saying here's marginal revenue, here's marginal cost. I'm going to supply this much and charge this price. Okay. Okay, so that's the simple linear demand example, and most of the time I'm just going to give you problems that involve linear demand because it's easier to work with. Fundamentally it's not different, but it's easier to work with. So we'll work with linear demand for the most part. So let's go one step further in thinking about what this difference between the competitive market and monopoly means. First of all, let me ask you this question. Is a monopoly a good thing or a bad thing?
Depends on your buyer or your seller.
Depends on whether you're a buyer or a seller.
Yeah.
I don't know, do you like monopolies? Yes? No?
Good in some places.
Like, good in
Power
some places?
lines,
You like monopolies for power lines? Why?
because it would be wasteful to have like 15 different companies all with power lines that are redundant.
Because it seems like it would be a waste to have each street lined with power lines from 15 different companies. They're all trying to get you to use their power lines, right? That's that argument. Sure, okay. What's wrong with a monopoly? Because you say sometimes it's bad, sometimes it's good. I mean, first of all, if you ask anyone who is in business, they will say, well, the thing you really want is market power, right? If you're in business selling anything, you want market power, and you'll pretty much do whatever you can legally to get more market power. So a monopoly is just about the best thing, right? That was your point. But as a consumer, you sometimes think, okay, well, let's think through this for a moment. If I'm in this market, I'm one of these, right? I'm one of these consumers. If this were a competitive market, if we had a bunch of small firms supplying this good, here's how much I would be paying. But since this is a monopoly, here's how much I'm paying. Right? That's the other side, the bad. Okay. Well, from an economic point of view, so we understand that, right? We can sympathize with that and say that sounds like a bad deal. But from an economic point of view, what's wrong with the monopoly? Yeah.
It has the deadweight loss, which would be the triangular area to the right of the your quantity sort of dotted line thing. Yeah. Right
there. And we call that the deadweight loss, which is true. That's true. But intuitively, what's the problem with that? I mean, the problem is this. Look, if you're a monopoly and you're supplying this much, who's buying? These consumers are buying up here. They are buying right here. Who's not buying? Everybody else on the demand curve is not buying. So, for example, what that means is, here's a consumer whose value is higher than the marginal cost of providing the product to this consumer. By how much? By this much. That's the difference between the value to that consumer and the marginal cost of providing the good to the consumer. And that's true for all of these consumers. For this next consumer, big difference between the value and the cost. Big difference between the value and the cost. For all of these consumers, right? All of them. Which means all of that value that could be created by supplying at the competitive level, all of that value is lost. That's the problem, as you're saying. That's what we mean by deadweight loss. What we mean is, there are a bunch of consumers out there, they would like to buy, their value is higher than it would cost to provide them, but they are not buying. Why not? Because this monopoly is choosing price to maximize profit. That's a short argument. Okay. So what that means is, by the way, being a monopoly in itself is not illegal. It's not illegal to be a monopoly, and there are actually good reasons why there are monopolies. If you read the chapter, you'll see some of these. I mean, one that we all know that is actually government mandated is what?
Post office.
Okay. I wouldn't call it a monopoly, though. Yeah. But what's a government mandated monopoly?
Patents.
Patents are, right? So patent is essentially a letter that the government gives you that says, you are the sole seller of this product for the next 17 or 20 years. So it's a government mandated monopoly. And of course, there's a reason why that's being done, right? So we can talk about that later. And being a monopoly in itself is not necessarily illegal, but there are lots of practices that are illegal that are aimed at getting more market power and maybe getting monopoly power. And we'll talk, that's kind of the next chapter. We'll talk about that next week, about regulating monopolies and the legal framework. There's an interesting Lawrence connection, by the way, here. What are the agencies that regulate this sort of stuff, that worry about market power and competition? What government agencies would do that? So there's the Federal Trade Commission, and they have a Bureau of Competition, and that was headed for a while by Bill Baer, who is a 72 Lawrence grad, and now he is Assistant Attorney General at the Antitrust Division of the Department of Justice, which is the other agency. Once when he retires in his older days, he'll come back to Lawrence and he'll tell us all about the interesting questions that arise. He's actually been very involved with Lawrence and was a trustee for a while. But I think when he got this current appointment, I think he was required to stop doing that. So he's not a trustee right now. But those are the agencies that deal with these questions. And part of the reason is right here, because we worry about that. That's it. Okay, do you have any questions right now about the welfare implications? So we'll get back to the monopolist possibly do better than this. Could a monopolist choose price or find a pricing strategy that would give a higher profit than what the monopolist could get this way? Okay? Questions later on. Okay, now that we know the basic theory, let's take a look at a kind of an interesting variation. So this is what we'll do next. We'll try to expand. Now we have a really basic theory. We'll try to expand it a bit. So here's a situation that's a little bit different. A monopolist is selling to a market. So we have a market with an inverse demand curve, and it's linear. We'll say it's linear. But this monopolist has two different factories, and maybe they even have different marginal costs. Okay, so two different ways of producing the very same product. And the monopolist will ship some quantity Q1 from this first factory and some quantity Q2 from the second factory, but it all goes to the same market. It's exactly the same product. Okay, so how would that monopolist maximize profit? Do you have a question?
No. I was going to answer the question.
Okay, so think about this for a moment. Everyone think about it. How would you, if you had to figure out how this monopolist maximizes profit, how would this monopolist do that? How much would come from this factory and how much would come from this factory? And I'm not looking for numbers, of course, because I didn't give you numbers for demand or for marginal cost. I'm just saying, in general, there is a marginal cost curve here, and there's a marginal cost curve in this factory, and the product is exactly the same. Think about that for a moment and try to work it out. Try to write down an equation that says, here's profit, here's how you would maximize it, here's what we would know when profit is being maximized. about costs and about quantities from these different firms, different factories, right? Think about that.
MC1 over MC2.
What do you have so far? Do you have the do you have an equation that says here's profit, here's the derivative of profit? Do you have anything like that? Yes? Yes? No? That's where you should start, right? You should write down, okay, if I'm going to maximize profit here, how would I do it? Well, what's profit?
Revenue.
Revenue minus cost. So what's total revenue in this case?
It should be price.
Let's have someone from one of those two tables in the back. What is it?
Price times quantity.
And what is price?
C minus D times Q.
So you want to say price times quantity. Price is C minus DQ. What is Q?
Q1 plus Q2.
Q is Q1 plus Q2, right? Because this is coming from two factories. Okay, so we need to multiply this by the quantity, but we know that that quantity is actually coming from two places, right? Okay, so so we have this C minus D Q1 plus Q2 times
Q1 plus Q2.
Q1 plus Q2 minus
TC1.
total cost, right? So we need total cost 1 of Q1 minus total cost 2 of Q2.
Yeah. And do derivative.
Okay, that's profit. And now we need to take the derivative of that and set it equal to 0 and see what that tells us. We take the derivative of that with respect to what? With respect to what? Q. Which one? Q1? Why not Q2? What do you think?
Maybe take partial derivatives.
Maybe do both, right? Maybe take the partial derivatives, do both. Because you are choosing both. You are choosing both Q1 and Q2, right? So if those are the decision variables, then we should take the partial derivatives with respect to both and set each equal to 0. Okay, well, what do you get if you take the derivative of this profit function with respect to Q1? So I'll let you think about that for just 30 seconds. See if you can go through and get the partial derivative, and then tell me what you get. If you notice an error, then you should let me know right away. So I'm bound to make a mistake, right? So you should let me know. You should make sure I'm doing this right. Okay, so we need the terms that involve Q1 only, right? So we have C times Q1, and the derivative of that is going to be C. We have minus dQ1 times Q1, and the derivative of that is going to be minus 2dQ1. We have Q1 times minus dQ2, and the derivative of that is minus dQ2. And then we also have, when you multiply this Q2 by this, that's also a term that involves Q1, right? So we also will have this Q2 times minus dQ1, and the derivative of that with respect to Q1 is minus dQ2. So it turns out that we have two of those. I think that's it for the revenue side. Yes?
Where did you get the minus 2dQ1 from?
That first one, this one, comes from when you multiply this Q1 by this minus dQ1, you get minus dQ1 squared. And the derivative of that would be minus 2dQ1. And then on the cost side, we have just the total cost function for Q1. So that's marginal cost Q1, and that should equal 0. Okay. So for Q2, what do you think? Can we just, if this is right, can we write down the same thing for Q2? If we went through, well, the way they appear in this formula right here, Q1 and Q2 are completely symmetric. They appear exactly in the same places. Okay, because we have Q1 plus Q2 in both places. So this should really be C minus 2dQ2 minus dQ1 minus dQ1 minus MC2 Q2. That should be 0. Okay, now take a look at that. What can we say about the profit maximizing quantities Q1 and Q2? Yeah.
Each factory will produce the same amount.
They will not necessarily produce the same amount. But, yeah, Maddie?
Why don't you include the total cost of the other one? So you subtract marginal cost of Q1 for the first partial derivative, but then you can also subtract total cost of Q2.
This total cost, TC2 of Q2, doesn't depend on Q1 at all. So the total cost for the second factory does not depend at all on the output of the first. So the derivative is just 0. The derivative of TC2 Q2 with respect to Q1 is 0. And then the derivative of TC1 Q1 with respect to Q2 is also 0. Yeah. So look at these two equations. What can you say about the profit maximizing Q1 and Q2?
Their marginal costs depend on each other's outputs. So like
The marginal costs don't depend on the other's output, right? MC2 of Q2, you know, it shows right here, it's a function of Q2. So it's not a function of Q1. Okay, what's this? If you simplified it, what does this say?
So it's almost like say minus 2 dQ1 minus 2 dQ2 equals to MC.
Okay, let's write that down. It says C minus 2 dQ1 minus 2 dQ2
equal to
equals
MC1,
MC1
also
Q1.
equal to MC2 Q2.
But that is actually exactly the same as this.
Yeah,
So that means it also equals
MC2.
MC2 Q2. So what can we say? We can say that at the optimal levels of output, Q1 and Q2, marginal costs in the two factories are equal. And they are equal to marginal revenue, basically. So, that makes a lot of sense. I mean, the profit maximizing condition for a monopoly is marginal revenue equals marginal cost. Well, what if you have two factories? Okay, marginal revenue still equals marginal cost in each factory. Why does that make sense? Because if you just imagine, so you're sitting right here, okay, you're supplying this market, and you need to decide which factory do I bring another unit from. Do I take it from here, or do I take it from here? Well, okay, I'll start here, I'll take one. But now, because marginal cost is increasing, now my marginal cost went up here. Okay, well, I should go to the other one. All right, I take one from here. Okay, but marginal cost went up because I took one from here. Okay, I'm going to take one from here now because marginal cost is lower. I will always take the next unit that I'm selling from the factory that has the lower marginal cost. What that means is that I'm actually keeping the marginal costs equal. As I'm deciding where I take the next unit from, I'm keeping the marginal costs equal. That's why we get this kind of result. Okay? Okay, so the next topic that we'll need to cover is price discrimination, which is a very important topic in pricing, and it's essentially asking the question,